Hello friends, my name is Sandesh and today I am going to start a new topic, electricity and magnetism. In this topic I am going to cover the B.Sc 1 physics paper 4 syllabus. So let's see what we will learn in this course. So in this course we are going to cover these topics. First one is complex number and their application in solving AC circuits. Basically we are trying to solve the LCR circuit using J operator and phasor diagram. We will see what is resonance in LCR series connection, also resonance in LCR parallel connection. Also we will see what is impedance, reactance, admittance and substitutance. After that we will see Owen bridge and what is the Q factor for the Owen bridge. Okay, so this topic I will be cover in the first chapter, that is AC circuits. Okay, so today what we are going to understand is complex number, because to understand the LCR circuit using phasor diagram we need to know what is J operator. For that we should know what is complex numbers. Okay, so first we will try to understand what is complex number, then we will proceed further. Okay, so let's understand what is complex number. Okay, we all know that there are two types of number system. First one is real numbers. Okay, there are real numbers, and second one is complex number, right? Second one is complex numbers. We all know that in real number there are two basic types. First one is rational and second one is irrational numbers. Okay, but we are going to focus on complex number. Why complex numbers are needed? Okay, so let's understand one scenario. Let's take an example. Let's say x square plus 1 is equal to 0. Okay, this is the equation I have and I want to solve this equation and find out the solution for this equation. Okay. If I try to solve this equation, I will get x square is equal to minus 1. Okay, but in mathematics this cannot be happen. Any square of any real number cannot be a negative one. Okay, cannot be a negative one. So at this point of time the mathematician realized that we should extend the idea of a number system. So they include this complex number in our number system. So they decided the number system should be combination of real numbers plus the number which can be represent this value also. Okay, so they decided to represent this value. It can be shown as square root of minus 1. Okay, and they have given it as iota. Okay, so it represented by the iota. So if any number can be represented by this number is nothing but an imaginary part of that number system. So that this number system will be called as a complex number. We have a number like square root of minus 25. Okay, so this number can be represented in such a way that square root of 5 square multiplied by square root of minus 1. Okay, so square root of 5 square is nothing but 5 and square root of minus 1 is nothing but this iota. So it can be represented in this way. Okay, so we learn that why there is need of complex number. There are such a situation that the solution of the equation is need to be represented by the square of a negative real number. Okay, in this, so they represented this number as a iota. So this number system is called as a complex number, which is denoted by Z. In this number system we have two components. First one is real part. Okay, we have real part, and another one is imaginary part. Okay, so real part represent a real number on a real scale. If I denote it on the scale, so here it is a center. Here we have 1, 2, 3 and so on. Here we have -1, -2 and so on. And this imaginary part can be represented on the y-axis. So here we have iota, 2 iota, 3 iota, and here negative iota, negative 2 iota, and so on. So this number system have a real part which can be represented by the real number, and another part is imaginary part. So this imaginary part, in this imaginary part, this iota is nothing but square root of negative 1, and square of iota is nothing but -1. Okay, so this complex number is very much useful when we try to solve some real case scenario like impedance in LCR circuits. Now let's try to understand the algebra of this real number. So in algebra of real number, first one is equality of two complex number. In a real number, we say that if A is equal to B and B is equal to C, in that case A is equal to C. But in complex number, how do we say that these two numbers are equal? Let's say I have first complex number Z1 and another complex number Z2. So how do I say that this first complex number Z1 and Z2, these two are equal? These two are equal if and only if the real part of Z1 should be the equal to the real part of Z2. Also the imaginary part, okay, the imaginary part of Z1, okay, the imaginary part of Z1, it should be equal to the imaginary part of Z2. If then only if the two complex numbers are equal. Next one is, what is conjugate of complex number? Okay, let's say I have this complex number Z1 is equal to A plus B times I. Okay, so A is a real part, B is imaginary part. So conjugate of complex number is represented in this way, and it is nothing but the negative part of imaginary part. So I can write the complex conjugate as A minus Bi. For example, if I have Z1 is equal to 5 plus 6i, so the complex conjugate of Z1 is equal to 5 minus 6i. Okay, so this is the conjugate of complex number. Next is addition of complex number. How we can perform the addition of complex number? Let's say I have Z1 is equal to A plus Bi, A1 B1, and I have another number Z2 is equal to A2 plus B2i. So addition of these two complex number Z1 plus Z2 can be written as A1 plus Bi plus A2 plus B2i. So I can write A1 plus A2 plus B1 plus B2 times I. So this is the addition of two complex numbers. Okay, so this is how you can perform the addition of two complex numbers. Okay, for the homework, let's say Z1 is equal to 5 plus 6i and Z2 is equal to 7 minus 2i, and you have to perform Z1 plus Z2. Okay, so the procedure is same. Here I have written the procedure. So you have to just put the value of A and B and find out the addition of these two complex numbers. Now let's see how we can perform the subtraction of two complex number. So let's say I have Z1 is equal to A1 plus B1 times I, and Z2 is equal to A2 plus B2 times I. So Z1 minus Z2 can be performed in this way. So we have Z1 plus multiply by -1 times z2. So this is how we can perform the subtraction of two complex number. So what we will get is this: a1 plus b1 times I, okay, minus a2 minus b2 times I. So here we have a1 minus a2, b1 minus b2 times I. Okay, so this is how you can perform the subtraction of. I'm not going to solve all this equation because I'm going to focus on physics of the LCR circuit. So this algebra you can perform by yourself. You have already performed this in your lower classes 11 12, but I'm revising all these things so that you can perform by yourself. Okay, so this is how you can perform the subtraction of two complex number. Let's see how we can perform the multiplication of two complex number. Let's say I have z1 is equal to a plus bi and z2 is equal to, let's take c plus di. Okay, so how we can perform z1 multiply by z2? So for that I am just writing a plus bi multiply by c plus di. So we need to just simplify this bracket. So first we have a multiply by c plus a multiply by d times I plus c multiply by b times I plus b bi multiply by di. So bi multiply by di will be equal to b multiply by d multiply by I square. So I square is nothing but -1. So in final we have AC plus in bracket AD plus C times B multiplied by I minus B times D, and I square is -1. So I am not going to write my 1 over here. So this is the final answer. Z1 is plus into Z2 is equal to AC plus AD plus C times B multiplied by I, and this is minus B times D. Okay, for homework, let's say I have Z1 is equal to 3 plus 2I and Z2 is equal to 5 plus 3I, and perform Z1 multiplied by Z2. So you can directly use this equation to solve this one. Just put A is equal to 3, B is equal to 2, C is equal to 5 and D is equal to 3, and you will get the multiplication of Z1 and Z2. Okay, and last one is how we can perform the division of two complex number. Let's say I have Z1 and I want to divide it by Z2. So this can be written as A plus BI divided by C plus DI. Now to perform this division, we need to multiply this equation by the complex conjugate of this Z2. So I can write C minus DI divided by C minus DI. So what we will get? We will get A plus BI multiplied by C minus DI divided by c plus di multiplied by c minus di is nothing but c square plus d square. Okay, you can further simplify this one. We will get ac plus bd plus bc minus ad times I divided by c square plus d square. Further simplify as ac plus bd divided by c square plus d square plus bc minus ad divided by c square plus d square times I. So here we can see z1 divided by z2. Here we have this one is real part and this one is imaginary part. So in all the cases, whether it is multiplication, addition, subtraction or division, in all the cases we have final product as a real part and this one is imaginary part. Okay, here also you can see this one minus this one is a real part and this one is imaginary part. In subtraction also, here we have this one is real part and this one is imaginary part. In addition also, here we have real part and this one is imaginary part. So this is how you can perform the basic algebra of uh, complex number. So today we learn about why there is the need of complex number and how we can perform some simple algebra of complex number. In next lecture I will show you how we can use this complex number in solving the LCR circuit problem. Okay, so stay tuned for the next lecture. In